Nerve Impulse Stop-Motion Film by Taryn Sager. Sodium-potassium pump maintains electron-chemical grading at the resting potential of -70 millivolts. This is a transmembrane protein that uses active transport to exchange sodium and potassium ions across the membrane. For every 3 sodium ions that it expels, it takes in 2 potassium ions. Some of the potassium ions will leak out of the cell. The inside of the membrane is relatively negative when compared to the outside, because -70 millivolts is the resting potential. Sodium and potassium channels open and close depending on the voltage across the membrane, which makes them voltage gated. When there is a signal at a sensory receptor or dendrite, the sodium channels opens and the sodium enters the neuron passively. The increase in sodium creates depolarization, which is when the membrane potential becomes positive. If there is enough change in the membrane or threshold potential is attained, the adjacent voltage-gated sodium channels will open. This causes a line of depolarization and action potential. This activates voltage-gated potassium channels so potassium passively exits. Repolarization occurs when the discharge causes the membrane potential to become negative. Before the neurons can refire, the original distributions of ions must be restored by the pump. The refractory period is when the neurons cannot make another action potential. This allows the impulse to travel in one direction. After the action potential arrives at the axon terminal, it prompts the opening of voltage-gated calcium channels. Calcium ions diffuse into the cell and trigger the fusion of neurotransmitters and vesicles with the plasma membrane. They are released by exocytosis and cross the synaptic cleft. Neurotransmitters bind to their specific neuroreceptors on the postsynaptic membrane. This opens lineated channels. There are excitatory and inhibitory neurotransmitters. Excitatory are lineated sodium channels, while inhibitory are lineated potassium or chlorine channels. Excitatory has depolarization, while inhibitory has hyperpolarization. The combination of messengers that dendrites get determine if the threshold is reached for an action potential. Neurotransmitters in the synapse are recycled by reuptake pumps or via enzyme activity are degraded.